So we're continuing to talk about light, and in particular we're talking about mirrors. And so we had a flat mirror, but the flat mirror is not nearly as interesting as our good friends, the concave mirrors. So there's a concave mirror, and there's another concave mirror, and they're probably not really all that in focus. And so this one, the focal length of this one should be in the neighborhood of 100 millimeters, and the focal length for this one should be in the neighborhood of 50 millimeters. And so what we're going to end, so this image right now is inverted and larger, and we're going to talk a lot about what these means in a second. And this is going to be inverted and smaller. And I'm just going to measure right now. I'm going to say that the distance to the paper to the and distance from the paper to the camera is about 25 centimeters. Okay, so roughly what we have is we have a situation like the following. I'm just going to jump in. I'm not going to do a schematic. I'm just going to jump in and do it as best as I can. Okay, so I'm going to say, I'm going to put a center right here. I'm going to get my circle drawer and put the center of my circle drawer on there and create, so there's a circular lens. Okay, and now I'm going to define on there, I'm going to define something that I'm going to call the optical axis. So I'm going to call this center, and this is the optical axis. And that passes through the center of the lens. And now I'm going to talk about what is the focus. So here I go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and a half, which is exactly, you know, that says 11 and a half right there, so it makes sense. So so I'm going to say that the focus for a circular lens is going to be the center, well, it's going to be radius divided by 2. So I'm going to go 5 3/4. 1, 2, 3, 4, 5, and there's half, 3/4 is going to be right there. And so I'm going to say that is the focus. Now I'm going to create some little I'm going to create a little person here, and so right on this line I'm going to make a little person. I'll make them, give them a hat so they end up right there. Okay, and now what's going to happen is I'm going to look at what effect there is on 3 rays of light. And the 3 rays of light that we're going to look at is, we're going to start with a ray of light that comes from the top of that person's head. So they've got a little light on the top of their head. Maybe they're mountain biking at night. And so that comes straight in. Now, angle of incidence equals angle of reflection. So, angle of incidence equals angle of reflection. So what I need to do is I need to make a normal. Okay? So a normal is perpendicular to a surface, and we know that the center to the edge is always going to be a perpendicular. So this is normal number 1. And I'm going to measure an angle, and that angle is going to be, I'm not going to come out exact, but this I'll get relatively close, 15 degrees. So what I need to do is I need to make angle of reflection, and the angle of reflection is going to be 15 degrees, so it's going to be like right there. And so my ray of light is going to come in along this line, and my ray of light is going to go out along this line. So this is light in, and then this here is light out. So light from their head is coming into my big huge mirror, and then when it gets to the mirror, at that point angle of incidence equals angle of reflection, and it goes out that way. Now, one thing that you notice is that the light that comes in parallel to the optical axis goes out along the focus. Now, the next thing that I want to do is I want to look at the light that comes in through the focus. So I want to do the opposite. And so I've got light coming in through the focus, and now I need another normal, so I need over here, I'm going to dot it. So this is normal number 2. And so now I measure this angle, and I measure that angle to be 11 degrees, and so I flip it over and I do 11 degrees on the other side as best as I can, and I come out to 11 degrees over here, and what I find is that the ray of light does a little something like this. And so now what I found is that a ray of light that goes in parallel to the optical axis goes out through the focus, and that a ray of light that goes through the focus, when it hits the mirror, it's going to go out parallel to the optical axis. And then the last one that I want to look at is what happens to a ray of light that goes right at the center of the lens. So if it goes right at the center of the lens, well, I already know that this is perpendicular to the lens at that point in time, so I can go pretty quick because I'm running out of time. And we're going to say that one is going to be about 12.5 degrees. So I'm going to flip around and I'm going to go 12.5 degrees the other way. Boom. And you're going to have to see what happens in the next video.